What's up, guys? In this video we are going to be finding the derivative of this. This is x to the power of 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 x up to an infinite number of powers of x. So the first thing we do is let's name this function. I want to name it y. So we're going to say y is equal to x to the x to the x repeated. Now our first step is we are going to say, since this, if you ignore the base and start here and go up to infinity, since it's still an infinite number of powers of x, this should also be approximately equal to x to the x to the x to the x. So whether you start from this or you start from this upwards, it's still the same thing. Even if you start here, it's still the same thing because it's still an infinite number of x's on the exponent. Now, since that's the case, then that means we can say that this is actually x to the power of y, because this is still equal to this approximately, very closely approximately. Now we have this. So what we are going to do here is apply the natural logarithm. We're going to say ln y is equal to ln x to the power of y. I applied the natural logarithm both sides. Now we have ln y is equal to, we apply the laws of logarithms, which say that you can take this exponent and make it the coefficient of the natural log. So I'm going to have y ln x. Now when you get here, what we are going to do is we are going to derive both sides implicitly. We're going to use implicit differentiation. So I'm going to find the derivative with respect to x of ln y. And then this side I'm going to find the derivative with respect to x of y ln x. Okay, so the derivative of ln y, I'm going to link a video at the corner of this video where I show you how to find the derivative of ln y deeply, but here I'm just going to apply the law that you apply. So the derivative of ln y is actually derivative of y, dy on dx, that's your numerator, divided by the function y. That's what the derivative of ln y is. So it's the derivative of this function, which is y, divided by the function itself, which is y again. Now we come to this side. For this side we have to use the product rule because we are multiplying y by ln x. Those are two functions. So first we find the derivative of y, dy and dx, and we multiply it with ln x. That's the product rule. Once again, I'm going to link the product rule at the right corner right there. Plus, and then we find the derivative of ln x with respect to x and multiply that by y. Okay, so now when we get to this step, we just need to make dy on dx the subject of the formula. So let's take dy on dx ln x and transpose it to this side. You'll have dy on dx over y minus dy on dx ln x, which will be equal to these guys. So the derivative of ln x is 1 over x. You can understand why that is so by watching the video that I linked for this guy, the derivative of ln y. So that's 1 over x, and it's multiplied by this y. Let's take dy dx as a common factor this side. Dy on dx. Dy on dx into, if we took out dy on dx here, we'll be left with 1 over y. If we took out dy on dx here, we'll be left with ln x. And then on this side, we have y over x. Y over x. Okay, now we just need to divide by this on both sides. If we do that, let's say divide by 1 over y minus ln x, so that we remove it and be left with dy on dx. And then we divide with it again this side, 1 over y minus ln x. This goes away. Now we know that dy on dx is actually equal to, you take this y as your top y. Now your denominator, since this guy is going to be 1 over this entire thing, the denominator is going to multiply with this x. So this whole thing is going to multiply with the x. So you have x into 1 over y minus ln x. The next step now is to try to simplify so that we can substitute the original function y back into this. So what I'm going to do now is I'm going to multiply through by x. I have y over x divided by y minus x ln x. Next step is dy on dx. We substitute x to the power of x to the power of x and so on. So this will be x to the x to the x repeated an infinite number of times, divided by, this will be x divided by y. Y is x to the x to the x repeated infinitely, minus, maybe you could say that this x can be the exponent of the x inside, but that's not useful in any way, I think. So let's just keep it as x ln x. Now the final step, which will give you your final answer, is the top part, you can't do anything to it, so you keep it as x to the x to the x repeated an infinite number of times, and then you draw the division line. Now here we have the same base, which is x. So you take the same base and subtract the exponents. So the exponent for this x is 1. The exponent for the x at the bottom is x to the x to the x repeated, minus this x ln x. So that's your final answer. I hope that helped you guys. Please subscribe, like, share the video, and come back to watch the next one.